All right, I think this is probably video 3 or part 3 in this series, impromptu series I've got going on. So I think on the last video, you guys are probably going to see the install inside the box here. In this video, I'm actually testing the lathe, making sure I've got the motor direction correct, which I don't, so I'm going to swap 2 wires over at the motor itself. I do have VFD control here of the lathe. When I was setting it up, I missed a setting. It was set to 400 Hertz and it was supposed to be 60, not the main setting. This was some other setting particular to this particular VFD. I would not buy this VFD again. The model is A2-8075. So if it was me, one of the things I would be looking for is something specifically that addresses unattended start. You can look that up online, but basically no matter what, even if the forward controls are engaged over here, I do not want this thing coming on. Now it does have a non-restart on loss of power. I don't know if that's the same as unattended start, it may be. And then the other very particular thing that I wanted is I wanted a free coast mode. So that has a mechanical brake. And I know everyone online seems to be in favor of a VFD braking system. I don't know if it's old school or what, but if it's got a mechanical brake, I want to be able to grab a hold of it and stop the VFD without it going into a fault mode. And so there's another video online where a guy actually hooks his VFD up to a foot brake, and it's got a provision for a free coast mode if a particular instance is set up. And so what it does is when he steps on his foot brake, it triggers some part of the VFD, some feature that allows it to free coast, and then he can stop it because the VFD is not trying to do either DC braking or controlled braking through the VFD. It just goes into, I believe, a free coast mode. Mine has a free coast mode, but you have to select it. In other words, it's either free coast or VFD braking. His particular VFD had a separate function that allowed him to set that up independently of his normal functioning system. I do have a brake resistor that I'm going to be putting in here. So the problem I'm having right now specifically is I have a thermal contactor on my relay, or my contactor. The contactor's in front of the VFD. I tried looking it up online. I cannot figure it out. There's no wires getting hot. I adjusted the little pot that's on the thermal overload to 1, which it looks like that's 1 amp, but I just don't know. I'm completely ignorant. I mean, I know how a thermal overload works, and I believe it has a bimetallic strip that opens. I'm not quite sure why it opens, so the VFD will start up and almost come up to speed, and then it trips the thermal overload. I've checked, my wiring's big enough. Right now I cheated, and I'm not even going to show you because people will go crazy, but I've got 2 wires into the VFD just to make sure the wire gauge is big enough. I'm going to convert it, or I'm going to change it over to a larger wire size, but right now I'm just troubleshooting, so this isn't permanent, and I'm not going to show you guys because you get all kinds of hate for it. So right now, getting the motor running the correct direction, pulling out the thermal overload switch. Something tells me you shouldn't have it in front of the VFD. I just don't know. I wish I knew more about, or I wish I knew why it was tripping, but for whatever reason it's opening up and it just drops the power out to the VFD while it's running. And then of course the VFD errors out and is mad because it's either low voltage or low amperage or whatever the error code is that comes up. So anyways, we'll get to it here, and I'm going to remove the contact or the thermal overload protection, get the motor changed over. I'm not going to show you guys any of that because it's literally just switching 2 wires, and then we'll see if that solves. Make sure, what I'm going to do is run the lathe, make sure the wires aren't heating up and I don't have some other problem, and we'll move on to some other stuff here. So part of this video is going to be me running the Cat 5, either 1 or 2 lines, over to the lathe so I can actually get my forward and reverse operation controlled over there at the lathe and not having to try to diagnose it here at the box. So that's part of this video, is the control wiring that's going to go from the box over to the lathe. So here's the thermal contactor. I'm just controlling 2 legs, and then I've got 2 hots and a neutral. Neutrals just pass through down into this neutral bus. And then obviously this is wrong. I've got basically 2 wires per leg, which I know is totally wrong, but right now I'm just trying to diagnose problems. So this is the contactor. I have this set at 1. It's got 0.75 and 0.5. And so I'm not going to go into that. I think it has to do with the motor rating, blah, blah, blah. It keeps tripping right here. When it gets hot, that sucker's coming out. So just going to do that here real quick. Okay, I got to move the neutral over. Oh boy, that almost doesn't reach. Okay, I know what we'll do. We'll swap. Alright, we're going to swap these 2. Get that neutral a little closer. Obviously I made it a little too short. Should have put a little bit more of a what is going on? Why won't that come out? What is going on? All right, so one of the things that I did wrong, being a newbie, I should have put the terminals that are straight, that crimp, ferrules. I'm sorry, I should have put a ferruled terminal on here, and I put these spade terminals, and you can see it's closed, and it's too big for the contactor, and so that was a mistake on my parts. This one obviously is unmolested for these, but it's been narrowed out because they don't fit in these contactors right. So I should have put I don't know what they call it. I call it a ferrule, but it is what it is. So we'll go ahead and get these tightened back down and move on with what we're doing here. I need to make sure that that is correct. Where does that go? That's correct. And then we're just putting these back in here minus the thermal overload. I didn't want to accidentally get these two just for the sake of testing. I didn't want to get these two confused since they're not numbered correctly or anything like that. So my numbering scheme corresponds with this. This is R and this is T, and then I've got these temps in here that are going to leave when I get a bigger wire in here. Obviously, some of you are going to have an opinion on this. I'd like to know why this thing trips when this is trying to power the lathe motor. Is it just improperly sized? I'm going to turn this thing on and check and see if it still works. Contactor's good. I don't know why I'm sweating so bad this morning. We'll test the jog. And then we're going to test the run stop function. Okay, what is the deal? Why are these contactors dropping out? What in the heck is going on? So apparently it's not the thermal overload. Something else is going on. What could be going on? Well, there could be an undercurrent or under voltage, which would cause the coil to disengage. Wish I was a better homebrew electrician. There's no wires getting hot. What could possibly be doing that? I'm stumped. All right. Turns out I literally missed this neutral. I got it behind the terminal instead of in between where it clamps down. I somehow stuck it behind and it wasn't making contact, or it was intermittent, and I literally found it by just wiggling the wire and this contactor would drop out. So got that put back, just tested it on 60 hertz, under a 30-second ramp, and it ramped up 30 seconds just fine. Definitely going to change that to, I'd like 5 to 10 seconds. I don't know if this VFD will handle it. So next, I'm going to go over here. Not going to show you guys. I'm going to swap 2 wires because it's running the wrong direction. And then I'm going to start addressing the low voltage wiring, which we'll get to that. I'll show you what's going on over there. It's a rotary drum switch. That lathe is a that lathe is a closing, and it has a 2-speed motor. I have the power tied in to the high speed, so you tie 1, 2, and 3 together, and then you hook to 4, 5, and 6, and I think it has 2 windings, and it probably ties the windings together. Again, I'm not an electrician, so that would just be guessing. It does have in the 1960s or 70s manual, it has what do they call that? Delta? Yeah, it's a delta wound motor, I believe. And so it ties in, the low speed ties in the middle of the winding. So maybe there's 3 windings and they're tying in the middle, so they're getting half the winding. Anyways, 1, 2, and 3 are tied in the middle of the winding. 4, 5, and 6 are at the corners. You electricians will know all about that. It's a delta motor. Again, it's all fuzzy up here. You guys will probably totally understand it. So, yeah, coming up to speed from scratch on this motor control stuff. Whew, man, it's like learning CAD all over again. Anyways, yeah, we'll get to it here. All right, guys, there's the twist lock. I've labeled the actual colored connections. Probably doesn't matter, but it does tell me what each terminal color is. So we've got red, black, ground over here, white over here in the back. And then I bought off of Amazon that flex connector. It just happens to be 3/4 inch for this motor. There's the actual nameplate. And then the original controls, I wire tied together, heat shrunk the ends, and then zip tied that whole thing off to another conduit, and it's just sitting back here out of the way where it can't be in this belt or anything else. This is all covered, by the way. I just have it off right now. So I have a separate problem, and that is that this front case here is leaking. It wasn't, well, anyways, it leaks, and so I'm gonna have to fix that. Probably gonna have to RTV a new gasket on there, but my oil level was originally full and now it's much too low, so I'll have to deal with that. So the next thing I'm going to do is, this is the mechanical switch here, the rotary drum switch, and all I'm going to do is set it up that that's forward and that's reverse through the VFD, and that's going to tie into this box here. And you can actually see the mechanical, well, you may or may not be able to see it. Let's see. You can see that shaft turning. And then this is the engage, disengage with the brake. Unfortunately, I can't use the electrical or the mechanical brake right now. We're going to work on that system at some point. But for now, I can't use it. Might require switching out this VFD. I don't know. So yeah, we'll get on to the low voltage stuff. All right, guys. So I got the low voltage in. I'll go over it with you guys. The connections are what I would call semi-permanent. So the one at the lathe I'm comfortable with. I've snuck it in under the cover. The previous guy that had it did some watertight connections, and they're great. I don't want to disturb those connections, so I just snuck the low voltage in the side of one of the covers. Not too worried about it. I'll show you the connections for that. I don't have a jog function yet because I really don't have anything on the lathe that's meant to jog, so I'm gonna have to set something up. I also don't have a potentiometer to vary the speed. So we'll get that stuff done a little later, but I'll go ahead and show you what the routing looks like and the cord relief and some other stuff. And we'll go back to the box, and again, the box is for sure temporary. I got to get a something for the wire to actually go through and be able to hold it. And the hole it's going through right now is pretty large, so I'm not quite sure how I'm going to handle that just yet. What I'd really like to do, well, I can't. Anyways, we'll look at it. So this rotary switch here makes the lathe. This is hooked up to the forward function on the VFD, and this is hooked up to the reverse function. Normally there would be a high and a low, but I've removed that because once you have a high-low, then I don't know how you can use a potentiometer with the high-low. Maybe you can, I just don't know how. So, anyways, it comes out of, this is the rotary switch, which I think I showed you guys before, and I've just got it snuck out here. And then I just zip tied the Cat 6 to the power wire. And that goes all the way around through that post there and then down into the panel. Now, I don't have a good access to the panel just yet, so it just comes down here and is temped in through a hole that was already drilled in the side. And it's not wonderful in here either, it's loose, but basically you've got green that's ground, orange that's hooked to the forward, blue's hooked to the reverse, and then one of these two down here is a jog function, which eventually I'm going to use. So I got to get that wire tidied up, and I still have to get, like I said, the other components to operate the jog and the potentiometer. And but I'll go ahead and show you guys that it works. So we'll power it on. So we'll go ahead and arm the system, let the main power turn on, and you can see that the red LED is on, which means there's power to the box but no power to the VFD. And we're going to turn that on. Contactors engaged, showing 60 Hertz because right now the control is at this panel. And then we're going to go back over here and we're going to check the actual function of the machine. So this is forward. And that's reverse. All right, guys, so I'm not quite sure where I left off on the last segment, but the controls for the lathe right now is when I switch to forward, it runs forward, and when I switch to reverse, it runs reverse, which is fine, but it's not how the original controls on the lathe worked, and I really want to return it back to the same control system that it had before. And so I'll show you on the front of the lathe the way it's supposed to work. So the way it's supposed to work is this is your direction selector, so you'd do that and it would be ready to go in forward. And then this would be down, and when you wanted to run the lathe, you'd go up and it would turn on. And then to go in reverse, you'd go there and that would turn the lathe on. And there's a, you can't really, well, you guys can see it. Whoops. This is the control, this switch for the on-off, the factory controls. Right now, I have all the switching done up here. I'm using this bus bar as my ground, and then these two contactors switch between forward and reverse. And I believe this is forward and that's reverse, or I don't know. Anyways, I figured out a way where I can run the ground instead of on this bus that automatically connects. I can run the ground through this switch by using the wires that come into this box that would normally actuate the contactor in here. And instead what I'm going to do, I'm going to leave all this stock, but I'm going to attempt to put a jumper from here, which is this wire right here. This would be T1. That comes in right here. And then I'm going to jumper up to this, which I'm going to use as my common or my ground. And then when this is switched on, when this switch here is on or engaged, these two contacts are tied together. So I should be able to take T2, which is hooked to this bus right here. And I should be able to jumper T2 from this contact to that one right there. So from here to here, I'm going to jumper. And so ground should come in, let's see, sorry. Oh, and I'm going to move this to this set of tied together relays. So ground is going to flow from here out T1. It's going to come in down here, across this contact. I'm going to jumper it up to here. Then when the power switch is engaged, it's going to flow across here through T2, and T2 is going to energize or ground. It's actually, I'm sorry, the wrong terminology. It's going to ground this bus, which is going to enable the run commands to come through these two wires. And that makes it so that I don't have to change anything for the next person. If there ever is a next person, I don't have to try to remember what I did. None of this stuff is connected to high voltage, so I don't have to make any of this work for high voltage. This is all being used as a low voltage system now. So power obviously goes straight into the motor via this cable right here. That goes directly to the motor from the VFD. So I'll change the wiring around and show you my janky ass jumper setup, but it just means that if I ever have to sell this machine, this can go to someone else and not be altered. So that's what I'm going to do. Alright guys, I figured out which set of wires to jumper. So if I switch it back and forth between forward and reverse, nothing happens. And if I lift this lever, now what I don't like is it shuts off at the very bottom of this motion, and that has to do with the adjustment back here. So that switch needs to be adjusted. It turns on too close to the position it's at now. I haven't figured that out yet, but this won't come on if this is in the off position. And then there's reverse. What I don't want it to come on as low as it is. I want it to come on somewhere up here, somewhere further up in this range. So that's just me adjusting the physical location. Excuse me. That's me just adjusting the physical location of that arm and that setup back in here. As far as jumpers go, so what I didn't realize was when you switch positions, it happens to junction these two here, which there's on this rotary box, all these back connectors are jumpered across the back here. There's a jumper that runs all the way down on every one of these except number 13. So I didn't realize it, but on that low 1 and 2, these two were being connected, and then this bus was connecting all these. And so I had to isolate it. You can see what I've got is I've got this jumper disconnected and pointing straight down here. I've got notes to myself for if I ever need to reconnect. There's a bunch of notes in here on what needs to be reconnected. But so now the ground passes from here out through these jumpers that I installed down here, like I said. So wait a minute, let me do this better. So so ground passes from here through T1. T1 comes out and goes here. Through here, T1 is now jumpered across to what would be the common for the switch. Yeah, the other part of the switch that switches on comes into this terminal, jumpers across to here. That is C. And someone mislabeled these horribly bad, but you can see, sorry, that's wires in the road. That's T2. So it comes out of T2, goes down here, goes back in here. T2 comes out and goes into this bus, comes across here, and when these are switched, these two terminals come down and contact this right here. And this whole bus is tied together. So when it's in forward or reverse, those two contactors you can see right there connect the ground through all that crap I did up through here, and it comes down and goes into this bus, and these are jumpered across to my forward and reverse circuits, and then these via Cat5 run back to the VFD and they tell it to turn on or off. So this works the way it should now. I have to adjust where this lever engages mechanically back there, but other than that, this thing's working the way it should, which I'm super happy about. I don't have a high-low, not a big deal. I'm gonna get a potentiometer and we'll do another video on that later. So I hope this helps. I know it's been kind of clear as mud. I'll try to answer any questions in the comments. If I need to do a follow-up video for someone particular to this piece of equipment, I can do that too. So anyways, hope you guys have a good day. Talk to you later.